Hi, sir.
Hey, hi Bharat. Hi Nirant. Hi Satvik. Just wait for a couple of minutes. Let's see who
Good
will
evening,
have
sir.
to join. Yeah.
Good evening, sir.
Good evening, Amtej. Just wait. Let's see who are able to join because Tania will not be able to join.
Good evening, sir.
Good evening, Nishant. Yeah, Satvik.
Good evening, sir.
Yeah. Good evening. Yeah. Tania, Shija, they all will not be able to join because today Navratri is starting. I think you all also have Navratri, right? Satvik, Bharat, others.
Yes, sir.
For us,
Yes,
it's
sir.
yeah. For us, anyhow, next week is a full holiday. Okay. So yeah, next week to ours a big celebration here. So you all also have
Sir, we do not have a holiday for Navratri.
no, not for Navratri, but you will be having for when the Sashti Saptami goes on in next week, right?
Sir, I don't know.
School will be holiday, right?
Sir, I have no idea.
Okay.
Sir,
Yours,
I
Bharat?
think we don't celebrate it
So
here.
finally,
I'm not sure.
today's okay. They gave us leave from today.
From
Till
today, na? Everywhere the leave is either from today or from Monday. The school will have leave. Schools will have leave because if you come to this part of India, literally you cannot put your land feet on land. That is like 1.8 crore people when they're on street. This is how it is celebrated in this part of
sir, but 12th standard people have school.
part 12. They have boards. They also have to finish they will have their pre-boards
Yes.
on January. There everything finishes before, right?
Yes, sir.
Sir, I'm not sure if it is celebrated here
In
in
Delhi
Delhi.
also Dashera is celebrated, right?
Yes, sir. The Shera is celebrated.
So 2 days before Dashera, one day before Dashera, we call it Navami. Okay. And before that day is called Ashtami and then Saptami we call. So all the celebration starts from there only. Not for Navratri. Navratri is a day in which actually the 10th day starts, right? All the
Yes,
first day.
sir.
Out of the 10 days, the first day starts today. So the main celebration will start from 5th and the 6th day. So the ritual starts from today, but main celebration starts that time.
So they
Sir,
might
I
have
think it will start from tomorrow.
Yeah. For us, it starts from today. Yeah.
sir, for me, sir, my math exams tomorrow.
Oh, Chennai, anyhow, it is very less. Hey,
Yes, sir.
Ayushman.
Sir,
Sir, but we get 10 days holiday.
our unit tests are starting from 8 October.
Oh, then so it's very strange. Very
So
strange.
like semester exam ended on 20th and unit tests are starting.
Oh, that's very, very strange because in this part, even like in Calcutta, if you go, literally, Ayushman, you are from Calcutta, right? From the West Bengal, right? So, you know what kind of crowd is there, in Durga Puja, right? Yeah, you will be knowing what kind of crowd is there, right? So it's like there will
So
be
you're
no,
saying,
yeah.
you're saying anything?
Yeah, I'm telling you will be knowing, like being in Calcutta, like what is the madness of Durga Puja and what is the crowd that is there.
Sir, it will be like a stampede here.
Yeah, it's like a stampede. Not a single vehicle is allowed on road. Not even a single vehicle. Leave car, leave anything. Nothing is allowed. Everybody has to be on feet. Like that. Once you should visit.
We think the locals are not like stepping out of the houses
Why?
like at because of the crowd. There is so crowd.
Yeah,
Like there is so it is not a environment there.
If you need the groceries, sir, then you have to definitely use Zepto.
There is no option. Nothing. There is nothing. Now you are talking about Ayushman, go to Park Street. You will see the madness there. Right? Till night 3, 4, it doesn't stop. Park Street, right? So that is the kind of madness, right? Here also same thing in Jamshedpur, right? I'll just recap because we did not do it. This is the last class of number theory. Okay. Number Fermat Little theorem and Wilson theorem we'll do together and finish it because that's the reason I was doing actually. Wow. Wait. The pen is not selected, right? Just hold on a minute. Now it is ready. Yeah. So there is an application I did not do. The reason because I was waiting for the factorial to get finished because the question that I wanted to do, one or two questions, very rare questions comes. So we know told that, right? If A is an integer and P is a prime number, A to the power P, this is what is Fermat's little theorem, right? Is like this, right? For example, if you take A as 2 and P as 7, right? So 2 to the power 7 is 128, right? So 128 you divide by 7, you will see the remainder coming to be 2. Same thing is 2 mod 7, right? 2 mod 7, if you see, it is nothing but 2. So this is one of the called Fermat's little theorem. More useful is this version of it because 1 is there. This version, if the HCF of A and P is 1, in this case, if I take HCF of 2 and 7 is what? It is 1. In this case, this holds true. Let's see. Right, 2 to the power 7 minus 1, which is 2 to the power 6, which is 64, right? 64, if I divide by 7, my remainder will be what? 1. Same thing happens here. 1 mod 7, sorry, 1 mod 7, it is 1, right? This version is the more utilized version rather than this version when the HCF of A and P is 1, because once you get to this stage, then you can start using the normal modular arithmetic, right? Like if I know A is equal to B mod something, right? B mod P, so I can write A to the power N is equal to B to the power N mod P. The reason it comes very strong because of the presence of this 1, because 1 to the power N anything is 1. So first, maybe there are questions when you will apply first this theorem, this line, you will observe that, okay, it is like this. Then apply this and then apply the modular arithmetic on that. So this is what it is, Fermat little theorem. Yeah,
Sir, what is X?
X not, it is into multiply, sorry, multiply. This is
1 into mod P.
1 into mod P. 1 I wanted to focus because this is the reason why 1 is very useful, because that's why this part of the Fermat theorem is used a lot.
Sir, like 1 into mod P, I don't understand what it means.
Okay, for example, I told you, right? Let me take A is equal to 2. P is 7. A and P are what? HCF of 2 and 7, right? A and P is HCF of 2 and 7 is 1, right?
Yes, sir.
Right. If I write 2 to the power, P minus 1 is 2 to the power 6, which is 64. 64, if I divide by 7, my remainder will be what? 1.
Yes, sir.
Same thing. 1 mod 7 is what? 1, right?
Yes, sir.
So
Sir,
this
like usually we don't write 1 into mod.
I did not want to write. The reason I wrote this 1 into like this to emphasize on this 1. This is the reason why the usefulness of this Fermat's little theorem comes. Because the moment you get mod 1 here, for example, if I have A is equal to B mod P, I write, I can use my exponential theorems. A to the power N is equal to B to the power N mod P. Right? Since here 1 is there, this 1 comes very useful because 1 to the power anything is 1 only. Got it? So I
Yes,
want
sir.
to emphasize, that's why I wrote like this. Generally, we don't write, right? But that's why I wrote like this because that comes useful. We try to always get 1, right? Or we try to get, right, questions have been there. We have tried to get A plus B whole square. I still remember, right? Some 10 to the power 4, something last 4 digit, right? This is how we solve. So this is the version that comes useful. Yeah.
Sir, this was also created by Fermat only.
Him only. He only. From him only. Okay, just write this because next question you will be requiring factorial. You will factorial not much, but factorial modular arithmetic format everything in single question. So this format, just write it down. Yeah, this format is what is needed.
Written, sir.
Others also written.
Sir, doubt regarding the exam, sir.
Doubt regarding exam means.
Sir, you asked my mother to enroll for an.
Acha AMO.
Yes, sir.
What is the doubt there?
Sir, is there any particular thing to study for the exam, sir?
No, like this only. There will be dominance of little bit of number theory and all the normal topics that comes, like you have given roots, right? Roots and cubes or that exam, right? Right,
Yes, sir.
RAM. Similar question paper will be there. Similar will be there, 15 objective. five 3 marks each, 5 subjectives, 5 marks each, 5 subjectives, 6 marks each. Seems easy, but it is not easy. When
Sir,
you
how much time will be given, sir?
90 minutes. 90 minutes. Even if you can do maybe 12, 13 objectives, and maybe out of this 10, 5 you are through. You are through. It's not that easy because, yeah, it's not that easy. Right? Because sample papers vary from real papers drastically.
Sir, so number theory I have to see, and
And the normal topics, normal maths topics that is there, that obviously will be there. But number theory, at least 6, 7 questions will be there.
Sir, like AMO, sir, I'm getting mails that these are sample papers you can try.
Sample papers are very different from actual papers, actually, you know. Like I had few actual papers I gave to my class 7 batch. Okay. Right. I gave to my class, and in the sample paper, they obviously they took their own sweet time. You take a PDF and do the real paper. I have put on the app with the timer and everything. Previously, it used to be simply 25 into 4, 25 subjectives. You have to just write the integer answer. It used to be this format. So I had a paper. So I uploaded in the app of that format, right, with a timer of 90 minutes. Right, in the sample papers, they scored 80, 82, but there the best score came 40, 52, 48, 44. This was scored by a guy who is SOF rank 1, international rank 1. So all are in top 50. So they scored like this. So it's difficult when you get the real paper with timer and everything. So things become very difficult.
Sir, like you have sent the AMO question paper in the
That was
app.
a sample paper. That was a sample paper,
Sir,
not a question.
sir, in this batch.
Yes, I have one question paper. I will send it. That was a sample paper, but not the real question paper. Real question paper is very different.
Sir, you sent, sir, the one paper you sent, it was sample paper.
Sample paper, sample, not the
Sir,
real.
that's why it was easy.
Yeah, that's why in sample paper, my 7th standard batch also they scored 80, 82. The moment the real paper came, 52, 48, 44, this was the kind of score that came. So, real paper was really good. Real paper will be good. That's why it's the strategy to, I always say, there is a strategy to attempt this kind of paper, right? Like 15 objectives, don't spend too much time on anything, right? Choose the 12, 13 ones that you can do, right? Because there are 3 marks. There are 2 marks, 12, 13 will be doable. Now comes a subjective. While you start the subjectives, first go through the 10 subjectives. Don't get greedy. First, to divide the subjectives into P1 and P2. Trust me, if you divide by P1 in the priority 1, which you know that can be doable or you think that is doable, divide into 5 sets or 4, 6, whatever you wish. Put your full time in this. Forget this P2. Don't hurry this because each will take time to solve. Each will take time to solve. I have one of the year's papers, so I know that paper. I've seen it. And one mistake, one single mistake, you are. It's not that there is no negative. People think there is no negative marking, so let me put anything. But you are not losing more than the marks. It's the time is the currency there, right? Suppose you have put 10 minutes in doing a 5 marks question, maybe one logical mistake or something happened. It's not about that you got 0 out of 5. What you more important, you lost those 10 minutes that you invested there. 10 by 90 divide, you will understand what fraction of time we lost, right? So it's okay to do 5 questions, 4 questions, whatever it is, but do accurately, right? Do accurately.
And
That's
sir,
it.
is there any negative marking?
No, negative marking is not there. So
Okay,
negative,
sir.
yeah. At
so
the
so
end,
yeah,
yeah.
so you're asking to do the things we know instead of like trying for the things we don't know at the first itself.
Yeah, there is there is no advantage to it, right? At the end, when 2 minutes are left, the objective you can mark anything, ABCD out of that you can mark anything, and just for the that's a wild guess you can put. There is no point, right? Because I saw that because I betted that nobody will cost 60 in my 7th batch. Those who are I have SOF rank 1 there, international 10 there, 28 there. The marks that I gave who all scored were these kind of people, right? Could not. I know they could not because it was tough. The real paper is tough. It will be just maybe 2 level below IOQM you can think of. SASMO and AMO are like that, right? If you are able to score 60% also, you will get through silver easily, right? So that's how it is. 60,
So you
65.
get medals for this exam.
Yeah, it is there. It is there. It's international. So it is there. Okay. This is the question. I will write before you all ask how it is, what does it mean, this statement. Wait. This is what it is.
Sir, we have to write an exponential form.
You have to, what is this is the number, this is what it is written here, I rewrote it. This divided by 19, what is the remainder?
Sir, so we have to write the remainder. Okay, sir.
Remainder I need, yeah. You will need Fermat's theorem for this. You will need it. Hey, hi Adhikari, I did not see you.
Sir, the original format prime is that a raised to the power a raised to the power p and a leave the same remainder when divided by p.
Use the second one. Second version will be needed there. A to the power p minus 1 is 1 mod p when a and b HCF is a and p HCF is 1.
Okay, sir.
Nope. No, Satvik. No, Bharat. Yeah, Lishant. Yeah. No, Adhikari. Fermat's little theorem is nothing. A to the power p minus 1 is equal to 1 mod p, right? 1 mod p when if HCF of A and P is 1. This is what is Fermat's little theorem. After Fermat's theorem, you will be required to think on modular arithmetic lines. First hint I will give you now. See, if I take A as 3 and I have to divide by 19, so P is 19. So 3 to the power 18 is 1 mod 19. There is a reason this 18 has come. That means if they think about this, can I express this number 5 to the power 11 to the power 7 factorial as 18k plus something? If I'm able to do it like that, literally my job is done, because 3 to the power 18 I know, right? If I can do it like this, like this entire number that is above, like 5 to the power 11 to the power 7, can I express 7 factorial? Can I express this as 18 into something plus something? If I'm able to do, it's done, right? I will break it as 18K plus something and it's done because 3 to the power 18K, I know it, right? It will be job done. Try to express this as 18 times something plus something.
Sir, I'm getting the same answer as before only.
No, it is not. No, Bharat, no. Apply modular arithmetic in this. See, 11 to the power 7 factorial is very easy somewhere. Think. If I want to express 5 to the power 11 to the power 7 factorial as 18 times something, it's other way around saying that I want to divide by 18. I want to divide by 18 and find the remainder. If I divide this number by 18 and find the remainder, I can say it is 18K plus something, right?
Sir, how did we get that 5 raised to the power 11 raised to the power 7 factorial?
It is given in the question.
Sir, like, why are we taking that only, not 3?
The reason because if I am able to express this part, entire part as 3 to the power 18K plus something, right? My job is done because I know 3 to the power 18K, I can break it into this and then can easily apply the mod AB formula, right? If
Okay,
I
sir.
Right, that's what I have to do, right? Because I have to use this 3 to the power 18, I know. So 3 to the power 18 time power anything will leave remainder 1. So my this part will go away. I will only deal with very small part then. So that's my target should be. How can I? So when I am saying try to express this as 18K plus something, in short, if I am writing, okay, our number is 18K plus something, that means I am again saying you this is a question. The question changes. Now this part divided by 18 will leave some remainder. So this is how you shorten the question up by going one step ahead and ahead, right?
Sir, like, I didn't understand how we got K and C.
K can be any number, doesn't matter to me. I don't need K and C value, right? If I say 3 to the power 18 is 1 mod 19, 3 to the power 18 to the power n is equal to 1 to the power n mod 19, right? So it doesn't
Yes,
matter
sir.
what is n. 3 to the power 18n is equal to 1 mod 19, right? I don't need that value also.
Okay, sir.
C obviously will be needed. C will come from if I treat this question as if I say divide 5, get the remainder when 5 to the power 11 to the power 7 factorial is divided by 18. If I know the remainder is C, I can literally write this number 5 to the power 11 to the power 7 factorial as 18k plus c, right? If I come get the remainder, right?
Yes, sir.
That's what we have to do. Yeah. No, remainder is not k. How can remainder be k? Adhikari. It is k times, right? Remainder is not k.
Sir, when I'm doing 5 past 6, then only it's 1 mod 18.
Exact. That is what you have to do. That's what. Now you have done almost 70% of the question. Then, so
Okay.
the
Then
5 to the power 6 you got, right? So if you see 11, then now second step should be 11 to the power 7 factorial. Can you express 6k plus something? You are done then.
Okay.
But got it? What chain I am going through, right? I got 18 here.
Then 11 past 7 factorial should be divisible by 6.
Not divisible by 6, but it's divisible by 6. Remainder will be easily
Remainder.
available then. Got it?
Yes.
Exactly. I'm going up the chain. That's what I wanted to think. Yeah, go up the chain. Use the power of, you are using 11 to the power 7. Are you able to identify for anything, Abhara?
Sir,
When you are doing 11 to the power 7 factorial, what are you trying to do there?
finding for mod 6.
So mod 6 can be first found in first step only, one step only.
11 squares, sir.
You don't need to go to square also. 11 only will solve it. What is 11 divided by 6 mod?
5, sir.
Isn't it -1 also?
Yeah, it's minus.
Use the negative one, funda, right?
Yes.
And then use the exponent both side. It's solved, right?
Yeah.
Right, that's what, right? Wait, 5 to the power 11 to the power 7 divided by 18, leave remainder of. No, 11 to the power 7 factorial when divided by 6, that will leave a remainder of 1. But this will not leave a remainder of 1. No, this will not leave a remainder of 1. This remainder, if I get, then the question is done. It's directly 3 to the power remainder divided by 19. That's it. This remainder is not 1. Let me show you, right? See, this kind of question, how the approach, how will I think? Okay. Okay, I see 3 here, I see 19 here. Okay, these two are prime numbers. Immediately it should click that I have to use Fermat's modular arithmetic. But I am here getting 3 to the power using the Fermat's theorem. Right, a to the power p minus 1 is 1 mod p. I getting 3 to the power 18, 1 mod 19. Okay, I'm getting like that. That means I have to, it is a very clear indication that I have to express this above power 5 to the power 11 to the power 7 factorial somehow as 18 times something as plus something, right? Plus something I have to express. That means all I have to do is I have to find this divided by 18. What is my remainder? Whatever that remainder will be there will be this thing, right? I want to find that. If I find it, my job will be very easy. So I have to find out. So I will think how to think around that line. So to make my life easy, again, I will think, is any power of 5 is there, which when divided by 18 gives me 1 as remainder? Yes, there is one power. If you try to do 5 to the power 6, you will get as 15625, right? This is 5 to the power 6. 5 to the power 6 is 1 mod 18. Divide this by 18, you will get remainder of 1.
Sir,
Right.
I did like, sir, 5 cube is 125, so it is leaving remainder -1.
You can square it. If you square that, it will give you 5 to the power 6 also, right?
Yes, sir.
It will give you, right? It will give you, right? 5 to the, that's any way you do, right? You can do 5 to the 3 and then go, right? So I know 5 to the power 6 is 1 mod 18, right? I know this, right? This is, sorry, sorry, known to me. When I'm seeing, that means 5 to the power 6 is this, my all things should be there. Okay, a power of 5, I got 1 mod 18. That means here power is what? 11 to the power 7. Now the power of 5 here is what? 11 to the power 7 factorial. My thinking will be, okay, can I now express this as 6 times something? Can I write this as 6 times something? Then to my problem is totally solved, right? If I get it, then I will be able to write 5 to the power some 6b plus 1, right? Already I know what is 5 to the power 6b divided by 18, I know. It will become easy for me, right? I know it. So how do I do it? So that means all I have to do is now my question reduces to, I have to find 11 to the power 7 factorial divided by 6, what is the remainder? Then I can come down the chain. I will show you how, right? 11, if I see 11, I can write divided by 6, the remainder is 5, right? I also taught you, right? I can write negative remainders also, right? 5 here means if I subtract 5 from this gets divisible by 6. But if I I can write it at like this also, right? That means if I add 1 to it, then also it gets divisible. So 11 is equal to minus 1 to the power minus 1 mod 6, right? So 11 to the power we will use if A is equal to B mod n. So we know A to the power n is equal to B to the power n mod n. So 11 to the power 7 factorial is equal to minus 1 to the power 7 factorial mod 6, right? Mod 6. Now 7 factorial will obviously have 2 in it. 7 into 6 into 5 into 4, 2 in it, right? So this is even. So this gives me 1 mod 6, right? That means 11 to the power 7 factorial, if I divide by 6, my remainder will be 1. So I can write 11 to the power 7 factorial as some 5 times anything, right? 5a plus 1, suppose. Anything, 5a plus 1. Because I know when divided, sorry, 6a plus 1, sorry. 6a plus 1. Because I know 11 to the power 7 factorial when divided by 6, remainder is 1, right? So my now this part, this 11 to the power 7 factorial, I will replace by 6a plus 1. So now my question I have to solve is 5 to the power 6a plus 1, I got it. Now I have to think 5 to the power 6k plus 1 divided by 18, what is the remainder? I already know 5 to the power 6 is 15625. If you divide by 18, you will get 1, right? So I will break it up into what? I will break it up into, right? We have did this, right? AB mod n is what? AB mod n when you do A mod n, right? A mod n into B mod n, right? That's what you do, right? And then total mod n, it becomes same, right? This is what we do. So I will split 5 to the power 6a plus 1 as 5 to the power 6a into 5. This I have to find the remainder, right? I have to find this remainder when divided by 18. That means I have to find the remainder of 5 to the power 6a plus 1. 5 to the power 6a plus 1 is just this, 5 to the power 6a into 5. So I have to find this mod 18, right? This is what I have to find, right? Now if I split it, it will become what? 5 to the power 6a mod 18, right? Right, into 5 mod 18, right? So what is my 5 to the power 6a mod 18, right? I know 5 to the power 6 is 1 mod 18. So if I take exponent 5 to the power 6a, right? A is an integer, right? It will remain same, right? 1 mod 18. So this will become 1. So finally 5 mod 18 is what? 5, right? So finally I know this number 5 to the power 11 to the power 7 factorial, right? 11 to the power 7 factorial, I can, because divided by 18, I am getting my final remainder as 5. I will be able to write at some, suppose 18b plus 5, right? This is entirely 18b plus 5. So this entire power part became 18b plus 5, right? Now 3 to the power 18b plus 5 divided by 19. So 3 to the power 18b plus 5, I can write it as 3 to the power 18b into 3 to the power 5. This I have to find mod 19, right? I already know 3 to the power 18 is what? 1 mod 19 from Fermat's little theorem. So 3 to the power 18n is 1 to the power n mod 19. 3 to the power 18n will be 1 mod 19. So this part, when I split it up, a into b mod 19, I will have one part as 3 to the power 18b mod 19 into, right, 3 to the power 5, right, 3 to the power 5 mod 19. This is what I will have. This part I know is 1. So I am left with what? Only this part. 3 to the power 5 mod 19. 3 to the power 5 is 243. Right? Just divide it by 19 and get the remainder. The remainder will come out to be 15 is the answer. The remainder will come out to be 15. Right? So
Sir, I
this...
didn't understand after we got 11 raised to the power 7 factorial uh, is equal to 6a plus 1.
11 to the power 7 factorial is 6a plus 1, right? Agreed?
Yes, sir.
So that means I can write this 11 to the power 7 factorial as 6a plus 1. I can replace it.
Yes, sir.
So it becomes 5 to the power 6a plus 1.
Yes, sir.
So I want to find this mod 18, right? That's what I want to find. The remainder when this 5 to the power 6a plus 1 is divided by 18. Agreed?
Yes, sir.
I can split 5 to the power 6a plus 1 as 5 to the power 6a into 5.
Yes, sir.
I want to find this mod 18. A into B mod 8 is. Mod is what? This mod this into this mod this. Agreed?
Yes, sir.
So which is nothing but 5 to the power 6a mod 18 into 5 mod 18. Agreed?
Yes, sir.
But I know 5 to the power 6 is 1 mod 18 because 5 to the power 6 is 15625. If you divide by 18, you will get 1. So if I take exponent also, 5 to the power 6a is 1 mod 18.
Yes, sir.
So 5 to the power 6a mod 18 is what? The remainder is 1. This is 1.
Yes, sir.
5 mod 18 is 5.
Yes, sir.
So that means 5 to the power 6a plus 1 when divided by 18 leaves a remainder of 5, right?
Yes, sir.
So I can write now 5 to the power 6a plus 1. I can write 5 to the power 6a plus 1 as 18 times something plus 5, right? I can write it like this, right?
Yes, sir.
So now I will, this entire thing that means I will wrote as, that's why I wrote 18 times b plus 5, right?
Yes, sir.
Again, I split this into 3 to the power 18b into 3 to the power 5. And I'm trying to find mod, right?
Okay, sir.
Now I know 3 to the power 18. Anything I do, again, it will get split into 3 to the power 18b mod 19, 3 to the power 5 mod 19. 3 to the power 18b mod 19 is 1. So I'm left with only 3 to the power 5 mod 19. 3 to the power 5 is 243. This you have to divide and get it. 15 will be the remainder.
Okay, sir.
Got it?
Yes, sir.
Others understood?
Yes, sir.
Bharat got it?
Yeah, yes, sir.
Interesting question.
Very much, sir.
Very much, no? Your favorite thing, like Fermat's little theorem and this thing is a favorite, right?
Yeah. I got till 11th bar 7 factorial and that's it. I was not able to get it.
Yeah.
The last part.
Last part. So that's why I am doing patterns, right? This pattern, I am telling you, how do you think? After applying also, there is a reason you have to think, okay, 18, I can break. If I have to break it into 18 means in the previous step, I have to divide by 18. Okay. In the previous step, I have to divide by 18 means something, I need some power of 6 which divided by 18 will give me 1 because 1 is the most favorable number, 1 and minus 1. If you can't get 1, try minus 1, right? These are the two things we try to achieve. Somewhere if I get 1, I can use the power, the most powerful are the exponent and this product, these two. So to use this, I need 1 or minus 1 here somehow. So we search for it, right? Right. Interesting theorem, right? Okay. So let's do, so I saw Mr. Ling, he hates this theorem. So enjoy this Wilson's theorem. Wilson gave another theorem, which told a natural number n, if it is greater than or equal to 2, is a prime only if n minus 1 factorial is, I generally write single, okay, single I write, okay, minus 1 mod n. right? Let's try to use a prime number greater than n. Let's use 7. So 7 minus 1 factorial is what? Wait, I will also do it. It is 6 factorial. 6 into 5 into 4 into 3 into 2. What it is? 30, 30 for the 120, 240, 720, right? 720, right? It is 720, right? 720 divided by 7. What is the remainder? Just check. Remainder. Remainder will be 6. No, yeah, 6, right?
Yes, sir.
Right.
714.
Right, remainder is 6, right? So, right, I can, so 6 mod 7, right? So in the right hand side, if you see, minus 1 mod 7, minus 1 mod 7 is same as 6 mod 7, right? That means from a number, if I subtract 6, that becomes divisible, or if I add 1, that becomes divisible. See, it is matching. So Wilson gave this logic theorem, so his name, this theorem came. Wilson's theorem.
Sir, does the converse of this theorem work?
Converse doesn't work.
Okay, sir.
Converse don't work. So just write it down. These are patterns, right? Just like you have a patterns in digits, this is a pattern he found and it became a theorem. Once noted, let me know.
Written, sir.
Others, Bharat written, others,
Yes,
Lishan,
written.
Yes,
others.
sir.
Okay, everyone written, right? So if you have written it down, then do a question. There is nothing to do, admire this one, right? So simple. This is simple one. I'm not just use Wilson's theorem and basic logic. And the normal modular arithmetic logic. That's all. Use the Wilson's theorem. Direct use Wilson's theorem and use logic.
Sir, I didn't get how Wilson's theorem will work in this question.
Yes, me too.
Directly, it will not work. 13 is the only thing that will help you in Wilson's theorem. Anything related to factorial, if you have to use 13, right? After that, you have to use the properties of factorial. Use the
Okay,
properties
sir.
of factorial. Directly, it will not get you. No issues. No, we just see the video.
Thank you, sir.
This is the last class of number theory. Just see this later. Okay. Use it. I know you are thinking if I use 13, I am getting different factorial. But that different factorial can be broken down, right? That's why I did factorial. I can break it down. Nope, Bharat. How can a remainder be greater than the divisor itself?
No, sir, that's wrong then.
Yeah, right. How can it be? Think about it, right? I'm giving you the hint also, right? Think about it. 12 factorial. I know you are dealing with 12 factorial when you are using 12 factorial can be written as 12 into 11 into 10 factorial, right? Think around those lines. I know when you are using Wilson, you are getting 12. So you are thinking how to do 12 factorial can be broken down like that, right?
Yes, sir.
Right? Now think. Now after that, it's normal modular arithmetic question. No, Adhikari, no. How can a remainder be a number I am dividing by 13? How can the answer be 14? Correct, Satvik, correct. No, Adhikari. Every answer is not one. Yes, Bharat. Saw the power of Wilson's theorem now?
Yeah.
So now which is powerful, Fermat or Wilson? Wilson is very powerful, right?
Yeah.
This is a very powerful theorem. Whenever factorial comes, the first thing should come to your mind is Wilson. Yes, Adhikari, right. Powerful theorem this is. Right? Now I will show you, right? So Wilson's theorem says what? N minus 1, if n is a prime number, then n minus 1 factorial is equal to minus 1 mod n, right? So here 13 is a prime number. If I use this Wilson's theorem, 13 minus 1, 12 factorial is minus 1 mod 13, right? I know factorial can be written like this, right? 12 factorial I can write as 12 into 11 into 10 factorial, because at the end I have to find 10 factorial, right? That is equal to minus 1 mod 13. But we know, right, at the end, there are three numbers, right? You can directly multiply also 12 into 11. It's not a very big multiplication, right? Anyhow, right? You can directly multiply and check also, right? But I know like A, B mod, at the end, what I is asking, there are three numbers, A, B, C, right? I know what it is saying, like A into B into C mod 13 is minus 1. That's what I will read it. That means this entire number, when I divide by 13, I get minus 1. So I can split it into, right? 12 mod 13, right? Into 11 mod 13, right? Into 10 factorial mod 13, right? 10 factorial mod 13, right? This is how I can split into, right? Is equal to minus 1 mod 13, right? Is equal to minus 1 mod 13, right? 12 mod 13. You will say, if I divide 12 by 13, my remainder is what? Remainder is 12. But I will say my remainder is minus 1 also, right? Because either you, when I say remainder is 12, that means if I subtract 12 from it, it is divisible. Negative remainder means if I add that, it becomes divisible. I will write as minus 1. Similarly, 11 mod 13, I will write it as minus 2. And 10 factorial mod 13, what did I do? Sorry. Oh, no, something I did mistake. Why did I did? Wait a minute, somewhere I did a mistake. 12
Sir,
factorial.
it's fine.
Fine, right?
Yes, sir.
Right, some mod or something I did not miss. Such a factorial also I have written, right? Mod 13 is equal to, yes, fine. I was searching where I have written, right? So minus 1 into 2, right? Mod. So 2 into, is it shaking? I don't know. Right. So minus 1 into minus 2 is 2, right? 2 into 10 factorial mod 13, right, is equal to minus 1 mod 13, right? Now, minus 1 mod 13 can also, what means minus 1 mod 13 means what? If I add 1 to it, then that number is divisible by 13. So I can write it as 12 mod 13 also. It's same, right? Because if I subtract 12, that number gets divisible by 13. If I add 1 to it, number gets divisible by 13. So I can write 2 into 10 factorial mod 13 is equal to 12 mod 13. Cancel 2 and 12. In this case, you can cancel it, right? Or if you don't want to cancel it, you can write it like this also, right? I just cancel because I know it will get cancelled. So I think you all would have been done like this, right? 6. So 10 mod 13 is 6 mod. So 10 factorial mod 13 is equal to 6 mod 13, right? So my remainder is 6, right? You all did like this, right? So the last step you can write as also like this. When you say 2 into 10 factorial mod 13 is 12 mod 13, right? I can also write it like that, that 2 into 10 factorial is nothing but 13k plus 12, right? I can also say like this. Think of it, 2 into 10 factorial, right? Because at the end, there is always a mod outside also, mod 13, right? I knew it will come, so I broke it, right? Finally, if I break it. So I can write it like this. I know this side is an integer. This side has to be an integer. So if I divide by 2, still remainder is 6. I know this will be taken care of because this is an integer. This side is an integer. This has to be an integer, right? So this will be 6. Did you get it? Others? Lishant, others got it?
Yes, sir.
Okay, cool.
Yes, sir.
Let's move to the next question. Next question is a little better one on Wilson's. use the previous question result, what you got. It's an extension. There was a part A, part B. You have to use part A, that previous question answer in this. Because you know what is 10 factorial mod 13. You know it right now. Last question we did. Nope.
Sir,
Nopes. 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 10 factorial mod 13 is 6 mod 13, right? Last question we did what? 10 factorial is 6 mod 13, right?
yes, sir.
So if you directly take power, it is not 1, right here.
Yes, sir.
It is not 1, right? So otherwise I would not have given this, right? Use that. This is the starting point. This kind of questions you have done previously. I'm telling you this.
Sir, like we have already used Wilson's to find 10 factorial. Do we have to again use it?
No, now you have to use the normal logic of exponent, right? Exponent. Now you have to, because you have to find 10 to the power, 10 factorial to the power 10. Now it's the game of exponent, how to play with exponents. How to
Okay,
play
sir.
around with exponent logic of modular arithmetic. That's all. No Adhikari, not right.
Sir,
Bharat,
I have a doubt, sir.
tell me.
Will there be a change when we cancel the 2 and 12, the previous question?
Tell me.
Will there be a change when we cancel 2 and 12 in the previous question?
Actually, you should not cancel it. That's why I showed you the other way around, right? Actually, you should not cancel because I know it is going to come. That's why I canceled it, right? Actually, you should not cancel. You have to use again the next step, right? Previous question. You have, that's why then later I put this bracket, right? Again, you have to find this, right? Mod breaking, right?
Yes, sir.
That's I did it just like I thought. That's why I then showed to that 10 that 2 into 10 factorial. I can write 13k plus 12, right? Normally also like 2 into 10 factorial, right? Is 13k plus 12, right? 13k plus 12. I know both sides are integer, right? So that's I wanted to divide and do like this. I know this will be divided by 2. This will be divided by 2. This is 6. This is you cannot cancel it like that. I showed it like that, but I meant that you have to again split it off, right? So I know this is an integer, this is an integer, so this has to be an integer, right? This is an integer, right? So then I confirmed, okay, if this is an integer and I getting this as an integer and this has to be an integer, so 6 will be the remainder, right? Got it?
Yeah.
Yeah, that's how I did it actually. You cannot cancel it actually. It's not arithmetic, just like that. Because you are able to do it because when you split it also 2 mod 13 and 10 factorial mod 13. 2 mod 13 is again coming to be 2 only outside, right?
Sir, I'm getting the same answer.
Nope. It is not. Let me think the logic that you have written. First of all, so multiply 6 5 times. Your multiplication is only wrong. Satvik. I checked my calculator. It is
Okay.
77776, not 8776.
Okay, sir.
Right. Multiplication is itself wrong. Do it step by step. I one use the class I did, right? You will finding 10 factorial square, then 4, then 4 into 2. If I combine, I will get 6, then 6 and 4. If I combine, I get 10. Do it step by step like that. No, no, Satvik, no. No, Adhikari, no.
Sir, I sent that by mistake.
Okay. Yes, correct. Correct. And so my logic was right. If you just say calculation mistake you did, that's what. See, these kind of questions are very easy, right? But I have to find, okay, I have to find 10 factorial to the power 10. If I think there is straightforward way, 6 to the power 10. If you are so keen on multiplying, multiply 6 10 times, divide by 13, you will get your answer. Simple, right? But doing it step by step makes sense, right? Step by step makes sense. Maybe I will be able to do little lesser way, right? I will be doing 10 factorial to the power 5. I will try to find, which is 6 to the power 5 mod 13, right? 6 to the power 5 is 77776. This is manageable, right? 636 into 36 into 6, right? This is manageable multiplication, right? If you divide 777 with 13, if I divide 777 with 13, my remainder will come as 2, right? So I can write 10 factorial to the power 5 is 2 mod 13, right? If I am getting this, all I have to do, again, apply the exponential thing, right? 10 factorial to the power 5 whole square is 2 square mod 13, right? So 10 factorial to the power 5 into 2 is 10 factorial to the power 10 is equal to 4 mod 13. So my answer is, that's all. Right? It was a part B. I just get it. Did you all get it, others?
Yes, sir.
Yes, sir.
Okay, cool. So let's move to the last question of number 3.
So 1 second, sir. Shall I
Okay, no
speak?
issues. It's not necessary that you have to do. You can do it like that also. 10 square also, right? If you want to do, if I want to, I can do it like this also. Anyway, you can do, right? I will think, okay, I am very lazy person, so I will not even multiply. Okay, 10 square is 36 mod 13, right? Casually I can do, okay, 36 divided by 13, right? Remainder is 10. I will write negative remainder. 39 is divisible. Minus 3 mod 13. Okay. Right, I can do it like this also, right? Okay. Let's meet then found 10 factorial to the power 4, right? Step by step if you want. Right. So it will be what? 9 mod 13. Right. Then I can do, okay, okay, if I square 4, I will get 8 and then I can multiply. Right. Then I can do, okay, if I don't want to even multiply this big number. Okay, 10 factorial to the power 8 will be 9 square mod 13, right? 9 square is 81. Sorry, 81 divided by 13. I know 78 is divisible by 13. So 81 will be remaining 3. Remainder will be 3. So 10 factorial to the power 8 is 3 mod 13. Right? I can do like this also. 3 mod 13. Okay. Now I have got 10 factorial and now I have got 10 factorial whole square. Let me multiply these two. Again, if I multiply and do also, I will be able to do it, right? Or where did I go? I can multiply this also. This is a smaller one, right? I got 10 factorial. If I multiply these two, I will get 10 factorial to the power 10 is equal to minus 3 mod 13, right? Minus 3 mod 13 into 3 mod into this is what 3 mod 13, right? 3 mod 13, total mod 13. That's what it is, right? A into B. This A in this I multiplied A, this I multiplied B. A into B, I have to find mod 13, which is A mod 13, B mod 13, overall mod. So this is what? Minus 3. Minus, and this is what? 3 mod 13 is 3. Minus 3 into minus 3 mod 13, right? So you are getting finally what? Minus 9 mod 13, right? Minus 9 mod 13 is same as 4 mod 13. So if you don't want to multiply, you can just do using mod also mentally. Right? You don't want to even multiply this much. So that's what I meant by step also, you can do it. Right? One step like this. If you want to deal, the moment the number gets bigger, I will search for its negative to make it smaller. This way can also be done. Or if you want to multiply 6 to the power 5, this way can also be done. Is this also clear?
Yes, sir.
Okay, cool. And this is the last question of number 3.
Sir, is Wilson going to be used in here?
Yes, you have to use it. It's a very similar question. We use that 10 factorial divided by 13, right? Similar question.
Okay, sir.
Right? Similar question, but little trick is there at the end. You know, the way you were cancelling, actually I was not cancelling, so cancellation won't work. What do you think Adhikari should be?
Sir, how is Wilson's theorem used in this, sir? I know it's from 37, sir, but
How I used in this questions? Just have a look at it. Wait a minute. How I used it, Wilson? Here, I used it, right?
yes, sir.
Right. Directly, it was not given 12 factorial, but I broke factorials, right?
Yes, sir.
Same thing you have to do. Break factorials, right? You have
Okay.
to break factorials. No, Satvik. So 36 minutes. No. I think you used Wilson's theorem wrong, Satvik. Just check once. Mod 33 it will be, right? And right side was not 12, right? Right side was something else in the formula, right?
Sir, I'm saying that 36. Sir, what I have written, sir, when sir mod 37, sir, only that part is 12, right?
No, it is not.
Sir, not 33.
Even if you
Sir,
write it mod 33, that is not 12. That is
sir,
not
I'm
12.
saying like, sir, I'm saying when we exclude 33 factorial and the three terms which I have written, sir, when 36, 35, and 34 are multiplied and they are mod 37, then we
How
are
are you
able
getting
to
mod
get the
37 will not be there, na? That's what it is.
why, sir?
What have we used in n, right? N minus 1 factorial is minus 1 mod n is the Wilson's theorem, right?
Sir,
N
one
minus,
second. Just give me. Uh, Sir, then, sir, the three numbers which I have multiplied, sir, their mod is, sir, this.
yes. This is the answer.
Sir, this is the answer.
Yes, this is the answer actually you gave. I thought you gave the answer, yeah.
Okay, sir. Sir, I'll see how I got the answer.
Okay. Oh, what has happened to Pranav, Bharat?
I don't know. Someone just feeling sick.
Yeah?
He's just feeling sick suddenly.
Okay.
Sir, like what I have sent, sir, this is what I'm getting.
31. That's what I'm thinking. How are you getting this? Mod 37 I can understand, but how 36 you are getting? Acha, 36, acha, you can write it as -1. I wrote it as -1 mod, okay? How 31 are you getting that side?
Sir, 36 into 35 into 34. Sir, like when I did mod 37 to each of them, I got -1 into -2 into -3. So that was -6.
Okay,
So -6 can be written as 31 in case of mod 37.
okay, that way you have done. Okay, okay, that way you have done.
Then, sir, how will we do it further?
And if you've done it right, if you write, break that 31 into 33 factorial into A into B, na?
Uh,
33
sir,
factorial 31. Take 31 to be A, right? If I am taking mod, that means 31 into 33 factorial. If I am dividing by 37, that is 31 mod 37 is 31 itself, right?
yes, sir.
And 33 mod 37 is what is needed, right? 33 factorial mod 37.
Yes, sir.
And other side is -1,
Yes, sir.
right?
Okay, sir.
Right.
Sir, what will be the next topic we will do?
Next topic will be quadrilaterals. So we'll be getting back to the your school syllabuses, but question level will be always be high. Yeah, but yeah, quadrilaterals and then what is there? I also forgot. Then mensuration. Yeah, mensuration is there.
Okay, sir. Sir, the 3D shapes and all.
Yes. What? I am also checking.
So,
Yeah, Bharat.
when will we do geometry?
Quadrilateral is geometry, right?
With angles. Quadrilaterals will be doing rectangles and other.
Parallelogram, rhombus, these
Yeah.
are all quadrilaterals, right?
Yeah, yes, sir.
Kite, these are all quadrilaterals, right? So,
We'll do it inside. We'll do
huh?
it inside. We'll do geometry inside quadrilaterals chapter.
Little bit geometry will be not geometry. I understand the question that you are asking. The detailed geometry that you are asking, na,
Yeah, yes, sir.
that we will do next year itself. Because mensuration this year have to be done detailed, right?
Yeah.
Mensuration cylinders are there, then your cylinders, and then what you call cone spheres, those are also there, right?
Yeah, yes, sir.
So those has to be, but quadrilateral will be deep, like parallelograms will go deep, rhombus and all those. Generally, quadrilateral comes what in your question? Generally, you have rectangles, squares. The tough questions you will get in rectangles, squares, then parallelogram, rhombus, that we will cover. So majority is covered only, except triangles we are not covering. That's what.
And sir, all the midpoint theorem, parallelograms with same base and between same base and parallels.
Those no, those doesn't come under mensuration.
Sir, we will do them next year then.
Yes, yes, because lot of mensuration is itself left.
Okay, sir.
The quadrilaterals we have to finish. Mensuration, lot of stuffs are left. Coordinate geometry is left. That also has to be done till 10. Coordinate geometry will do till 10th level. That is left because that is
Sir,
more
we'll do
important because I will be
coordinate
needing
geometry
that.
also this year.
Yeah.
Sir, we'll do coordinate geometry also this year.
Yes, coordinate I will emphasize more. Because we emphasize more. The similarity, variety, everything we will do and finish it next year. Because those are just like number theory that will require me 10, 12 classes. Congruency, high level of congruency, then high level of similarity and high level of all those questions. Because those are very lengthy topics. And
Yes,
there
sir.
comes
Sir,
lots of theorems, Apollonius theorems and all those.
sir, like in our school there is a batch called Aryabhatta.
Okay.
So in that they teach us like high level maths. Sir, like this only. So right now they are doing midpoint theorem. Uh, sir, all the
Midpoint theorem is
nine.
actually there in basic ninth only, I think so.
Yes, sir. Sir, like ninth topics like. Sir, basically they do from R.D. Sharma and NCRT only.
Ha.
Sir,
Ha, see
like
that?
ninth R.D. Sharma and a little bit of 10th.
Yes. So there are two ways of doing. See, whenever you do, right, the topic, right, there's a two-way, right? For example, there's two-way. Either you can go to ninth. See, if you go to ninth, 10th also, there is nothing, right? If you just yourself only open the R.D. Sharma NCRT, you all yourself will know it. That you yourself can alone do it, right? But there is a one way in which you just go higher up the classes and increase the difficulty of the question. Second way, within the, because if you see the second way is the within same class concept, like when I will be doing, there will be so tough questions on squares and rectangles you will see, right? When we do it, right? So within the syllabus only, the toughest question when you have to think.
Yes, sir.
So I generally prefer this direction better. This direction better because that's where you will require this to, in Adi Sharma 9 also, if you start doing it yourself also, you will be able to do. There is nothing very simple things, right?
Yes, sir.
The tougher questions within the syllabus is what is makes it tough.
Yes, sir.
Right, so this was very easy one, right? I can use the Wilson's theorem, right? Wilson's theorem says that if a number is prime, then n minus 1 factorial is equal to, I mean, congruent to minus 1 mod n, right? I will take n as 37. So 37 minus 1, 36 factorial is, I'm just writing equal to, okay, is equal to minus 1 mod 37, right? So 36 factorial, I can break it. What's the time? Oh my God, next class is also going to start. Yeah, I have to write it as what? 36 into 35 into 34 into 33 factorial, right? Is equal to minus 1 mod 37, right? So 36 divided by, now again, these are what? A, B, C, and D like that. I can take separate mods. So 36 divided by 37, I can write as minus 1, right? Remainder as minus 1. Similarly, 35 divided by 37, I can write remainder as minus 2. 34 divided by 37, I can write remainder as minus 3. Into 33 factorial is equal to minus 1 mod 37, right? Minus 1 mod 37, right? So this is what? Minus 6 into 33 factorial is equal to minus 1 mod 37, right? 37, right? You can cancel this minus, right? 6 into 33 factorial, right? If you again break it up, right? Same way, if you break it up, you will end up seeing that 37 minus 6, 30, yeah, 31 will be the answer, right? You will just break it up. You will again do the same step. You will get 31 as the answer. So this finishes the, right? So this finishes the entire number theory. How was it, everyone?
Sir, very nice. Sir, like most interesting topic of maths I found.
Yeah, it is. It is. Bharat, you?
Sir, I'm just sad that number theory just ends right now.
What?
I'm sad that number theory ends.
If you want to do on your own, few theorems that I did not do, Euler's theorem and Cartesian's theorem, a couple of theorems, and Chinese remainder theorem, those things you can study on your own. But yeah, but these things are one of the majority. What I did are the things that will be requiring you in IOQM and other things. But yeah, even the questions that now I will be doing, don't think that it will be 8th standard. You all have seen my comparing quantities and other chapters, right?
Yes, sir.
Right? Questions will be IOQM level questions, even in quadrilaterals, right? Every chapter we will be doing the best. So Adhikari is telling that I am happy this got ended. Right? He's telling me. Right. Ayushman,
Yes, sir.
how did you like this number theory finally ended?
So I'm feeling sad about it. I'll continue to practice number theory.
Yeah, continue the practice. Lot of questions on number theory. If you search, you will get it, right? I am damn sure it's the same, all that 16 classes that I have given, 16 into 4 is the average questions per class. 64 questions. If you try it next year, na, for first shot, you will not be able to do for 50% of the questions because many things you will be forgetting. Many things, yeah. And that's all. That's it. We'll starting quadrilaterals next class. And by the way, next week there is no class because of Durga Puja and Dashera. So wish you a very happy Durga Puja, Dashera, Navratri, whatever it is for you all. Okay. So enjoy it. Okay. So next week there is no class for that. Okay. So yeah. So we will meet only next to next week. Okay.
Okay, sir.
Okay.
Bye, sir.
Bye everyone. Have a great
Bye, sir.
time.
Bye,
Bye
sir.
bye. Bye. Bye.